2.6 System of linear inequalities. Now, when we do a system of equations, we're talking about two or more inequalities. Okay, so a system of equations would be two equations. An example of that would be graphing two lines. Let me do that again. If I have a grid and I graph a line and then another line, the solution would be their intersection point, and we would create a coordinate and have the solution. When we have a system of linear inequalities, now we're talking about graphing two linear inequalities. Sometimes they'll be dotted, sometimes they'll be solid, and we have shading. And where their shading overlaps is where your solution region will be. So let's take a look at an example here to see what that means. Alright, here are two simple questions because we're graphing one variable. Now, anything that's of the form y, let's do y equals 4 for example. Y equals 4 is a horizontal line at 4. So it looks like this. But on here, we have a different situation. Because we have an inequality. So we'll just do the same thing. We'll graph 4, 1, 2, 3, 4. Okay, so it's going to be right here. But the inequality is a less than, so it's going to be, there's no line underneath it, so it's going to be dotted. And you know what, I'm just going to stick with by hand. But we also have to decide shading. Well, what y's are less than 4? So we have to shade down here. Now the next one, well, if we look at the x, well, x is a vertical line, in this case at -1, and it would look like this. Sorry about that. It's a vertical line right there. So on this graph, we would go to -1. It has a solid line underneath the inequality, so it is solid. But then again, we have to shade properly. So what x's are greater than negative or equal to -1? Well, that would be to the right. Now, where are the solutions when you have something like this? Well, it's where the shading overlaps each other. So in this area, you have both red and blue shading. So that would be the solution region. Any coordinate in this solution, in this region, would work for either equation. So if I picked a point over here, it would not work for either of the inequalities. If I picked a point over here, it would work for just blue. If I picked a point up here, it would work for just red, and then of course anything in the yellow would work for both. So something more traditional, we take a look at this one first. Y-intercept of 3, slope of -6 over 1. So 1, 2, 3, 4, 5, 6 over 1, and so on. We would have a dotted line because it's less than and not less than or equal to. Remember, the line underneath it will decide if it's solid or dotted. So this is dotted. We would have to shade greater than or less than. Well, this is a less than. So we want y's that are less than that, so it would be below the y-intercept, and that would be down here. Anything in that area. The next one has a y-intercept of +2 and has a -1 over 1 slope. So down one to the right one, down one to the right one, etc. And that does not have a line under it either, so that is dotted. And it's less than also, so we would shade below that one. And again, it's where they overlap, where their shading overlaps, that your solution region is. Okay, so again, if I picked a point over here, it would not, that coordinate would not work for either equation. If I picked a point, and this should have gone further. If I picked a point in here, it would only work for blue. If I picked a point here, only red. And then if I picked a point from the yellow, it would work for both. Here we have to solve for our y again. So now I'm going to subtract x. So I get 3y is less than negative x plus 6. Divide by 3. And I get y. And I'm dividing by a positive, so my inequality does not change. This becomes negative 1/3 x and plus 2. So this gave me negative 1/3 x, and this gave me a 2. Next one, we have to subtract 2x, and we get y is greater than or equal to negative 2x minus 3. So let's graph the first one. Y-intercept of 2, slope of negative 1/3, so down 1 to the right 3, up 1 to the left 3. It is in less than with no line underneath it, so it's a dotted line. And it's less than, so we would shade below. The red has a y-intercept of negative 3, a slope of negative 2 over 1, so down 2 over 1, and then up 2 over 1. That does have a line underneath it, so this is solid. And it's greater than, so we would shade above that red line. So our solution region would be where they overlap again. So everything in here would be the region that we would say contains all solutions. Again, for clarification, any point up here would work for just red. Any point over here would work for just black. So, and then any point over here would work for neither. All right. So, in order to be elected President of the United States, candidates must be at least 35 years old and win a minimum of 270 votes. So define the variables and write a system of equations. So let's go with A for age and V for votes. So what does that mean? Well, A, the age must be at least 35 years old, which means 35 or 36 or 37 is good. So greater than or equal to 35, because 35 would work. I'm going to do the V in blue here. And the votes must be a minimum of 270, so greater than or equal to 270, because minimum of 270 means 270 is okay. Now we have to graph this, and I'm going to put age below and votes on the top. Now I'm going to go, for age, I'm going to go 10, 20, 30, 40, 50, 60. I'm going to go to the right. So I'll go by 5s, but I'm only going to write something down every 10. So 10, 20, 30, 40, 50, and 60. Votes, I'm going to go by 100, by 50s actually, but I'll just write the hundreds in. So 100, 200, 300, 400, and 500. So how do we graph these two? Well, first of all, A is greater than or equal to 35. Well, 35 is here. It's greater than or equal to, so I'm going to draw a solid line. Whoa, that didn't work well. Try that again. Having trouble with this here, so hang on. There we go, solid line at 35, and everything greater than works. Okay, now the votes must be at least or a minimum of 270, so here's 200, 250, 270 would be about there. I can include 270, so I'm going to go right across, and everything greater than that works. So where's our solution? Well, the criteria to be elected would need to be in here. So having that amount of votes and being the right age. Now a question says, name one possible solution. Well, we can pick a lot of them. In this yellow region, we can pick one. I want to pick this one right there. And that coordinate is the coordinate 55, that's the age, and they got 500 votes. That's a possible solution. Next question says is this coordinate a solution? So let's find it. I'll put it in yellow. 52 would be right about here, and 235 would be about here. So if I went and found their intersection point, it would be about here, and that would work for red, right age, but not enough votes. So this would be no, because of the location, and because, in other words, age is okay, but not enough votes. This ends lesson 2-6.